Math 8, volume of composite solids. Examples. Find the volume of the composite solid. Round your answer to the nearest tenth. Okay, the method I'm going to demonstrate here would be to create a new formula equation for each composite solid and then plug in all your unknowns and solve. So, the volume of this you should recognize as being a cylinder plus two hemispheres, which could go together to make one sphere. Now, looking at the cone, not the cone, the cylinder and the hemispheres, they all have the same radius. So, I'm going to do the cylindrical part, pi r squared h, and since the r is the same, I can just do the sphere as 4/3 pi r cubed. Now, identifying some information, we have, of course, the r. R is just 2 inches, and that's the same as the r in the sphere formula. So, we need to identify h. Now, h, this is going to take a little bit of work. It is 8 inches total from end to end of this solid, which, by the way, is called a capsule. Capsules are seen in the shape of, well, medicines get put into capsules. Also, propane tanks could be this shape. There are some other things, I'm sure, as well. But anyway, the overall length of this capsule is 8 inches. We need to take off the hemispherical pieces to figure out what is left in the middle. Now, the way we're going to do this is realizing that the radius of the sphere is 2 inches. The distance from the center of the hemisphere here to the end is going to be 2 inches. And the same will be true on this other side, 2 inches. 2 inches and 2 inches. To make 8 inches, we need an additional 4 inches. So, the height of the cylinder is 4 inches. From there, we can go ahead and plug things in. We've got pi 2 squared times 4 plus 4/3 pi 4 to the third power. Now I can type this all in at the same time. Pi 2 squared times 4 plus 4/3 pi times 2 to the third. It is 2 to the third power. I almost made a mistake there. Make sure you're plugging in the radius for the radius. Anyway, that ends up being 83.775. I'm going to round that to 83.8, and the units here would be inches cubed. So the volume of this capsule is 83.8 cubic inches. This capsule would be much too large for you to swallow as a pill and too small to be very useful as a, well, it could be useful as a propane canister. Find the volume of the composite solid, round your answer to the nearest tenth. Now this one, you should notice, is a cylinder plus a cone. Now this shape could show up in the shape of a silo that has the cone shape at the bottom, which allows you to just open up some sort of apparatus here, and gravity will make all the grain fall through. You don't have to have any type of machinery inside to feed it through the bottom. Gravity does all that. So it's a nifty design for a grain silo. But as we look at this, this would be pi r squared h plus 1/3 pi r squared h. Now let's look at the r's are the same or different. As far as the radius, it looks like the radius of the cone and the radius of the cylinder are both 3. The heights, however, are different. Since they are different heights, I am going to add some indexes here. This we're going to call h1 and h2. h1 being the height of the cylinder and h2 being the height of the cone. So h1 is 9, h2 would be 5. Now we just plug our information in. So the volume of the cylinder is pi 3 squared times 9. And we're going to add the volume of the cone, 1/3 pi 3 squared times 5. And then it's just plug all this in, pi 3 squared times 9 plus 1/3 pi 3 squared times 5. And that gives us 301.5928, etc. That'll round to 301.6. And this would be measured in meters cubed. Okay, quick recap on this. What we did here is we decided what makes up the shape. We created a formula. We had to do some indexing for our different variables because the heights were not the same for both of them. We identified our three known values, radius, height 1, and height 2. Then we plugged the numbers in. We used our calculator to type the things in, did a little bit of rounding, and we got our answer. Okay, next we're going to look at a multi-step problem. A soybean silo is made of a cylindrical section with a hemispherical roof section as pictured. By the way, a hemisphere is half of a sphere. We live in the northern hemisphere of the Earth. Hemisphere is half of a sphere. The average soybean yield for 1 acre is 40 bushels. 1 bushel is about 1.28 cubic feet. Assume the entire interior volume can be used for storage of soybeans. How many acres of soybeans should you expect to be able to harvest and store in the silo? Now, we are making an assumption. Now, in a real-life model here, you aren't going to be able to get soybeans clear up into the top of this because there's a little door here. But we are going to assume all interior space can be filled with soybeans. Okay, so the first thing we would do here, let's plan things out. We were obviously going to have to find the volume of this solid, this silo. After we find the volume, we need to convert the volume from cubic feet to bushels. And once we do that, we're going to have to calculate the acreage, the acres that can be harvested at 40 bushels per acre. Okay, first we find the volume. The volume here I recognize as being a cylinder plus 1/2 of a sphere. So I'm going to create a formula that will do precisely that. The cylinder, of course, is pi r squared h, and the half sphere, the hemisphere, is 1/2 of 4/3 pi r cubed. Now, we do have an r in both parts of this formula, so let's double check to make sure the radius is the same. The radius of the cylinder is marked at 12 feet, and that's actually the radius of the hemisphere as well. So the radius is the same for both, so we're good just to call it once. So we need the height and we need the radius. The overall height here is 52, but we need just the height of the cylindrical portion. So we've got to do a little bit of figuring here. Up top, we've got the hemisphere that is not part of the cylinder. We just need to know how tall that is. Now again, we'll do the same thing we did back on the capsule problem. The radius of the sphere is 12 feet. The radius of the sphere going straight up will also be 12 feet. So we need to take 52, the entire length, subtract the 12, and we will get a height for the cylindrical portion of 40 feet. The radius, as I've mentioned, is 12 feet. Okay, we are good to go with plugging this in and finding the volume now. Pi 12 squared times 40 plus 1/2 of 4/3 pi 12 cubed. All right, now I go to the calculator. Pi 12 squared times 40 plus 1/2 times 4/3 times pi times 12 to the third power. And this gives me quite a large volume, 21,714.688. It doesn't say what to round things to. Since I'm not at the final part, I'm going to go ahead and round it to 2 decimal places, and that will give me a little bit more to work with later. So, at this point, we figured out the volume of the section we have. I'm just going to shrink that off to the side, leaving the answer in full size. We need to next convert the cubic feet to bushels. Now, if you're good with your proportional reasoning, you'd know whether to multiply or divide, and you'd be right there. If you are a little bit unsure with whether you would take this number and multiply by 1.28 or divide by 1.28, you can always set up a proportion, which is what I'm going to demonstrate. According to this information here, 1 bushel is the same as 1.28 cubic feet. And the information we have from the problem is 21,714.69 cubic feet, and we have X bushels. I'm not sure exactly what the abbreviation for bushels is. I thought it was BS, but that might be BS, so I'm not sure. But we can continue on with this. It looks like what we end up having to do here is divide by 1.28. And if you already knew that that was going to be the case due to proportional reasoning, then by all means, take that shortcut. Okay, on my calculator, I've still got that previous answer. I'm going to retype it with what I approximated there. And this gives you 16,964.6 bushels. Okay, that's quite a bit of soybeans. A lot of bushels of soybeans. So next, we're almost there. We had planned from there, after finding the volume and converting it to bushels, we need to calculate the acres that can be harvested and fit into that silo. Now, assuming 40 bushels per acre, and we have 16,964.6 per X acres, we can just set this up as a proportion. And again, if your proportional reasoning skills allows you to know whether to multiply or divide, you don't have to go through this step. But I am demonstrating it for those that are would be unsure. When I cross multiply, I get 16,964.6, and that equals 40x. I'm going to go ahead and divide both sides by 40. So divide 40. I'm going to round this to the nearest full bushel. I get 424 bushels. Not bushels, it's not bushels. If I look back at what I was figuring, I'm trying to figure out the number of acres. So that's 424 acres of soybean fields that could be harvested into this grain silo. Okay, thank you for watching. You can replay this video if you need to further understand things.